This triangle is full of secrets. I've already told you about some of these secrets, but the surprise is that it is not over. Today I'm going to share another secret about K and Pascal's triangle with you. So what I want to share is that if I pick any of these rows, let's say this one, and I start from the rightmost number and multiply it by 10 to the power of 0, the next one 10 to the power of 1, the next one 10 to the power of 2, and this one by 10 to the power of 3, then the result for this one is 1331. And if you check, it is actually 11 to the power of 3, which is 11 to the power of number of row. If you check it for any of the above rows, for example, for this one, it is going to be 121, which is 11 square. For this one, it is 11, which is 11 to the power of 1. And the top one is actually 11 to the power of 0. We can check it for every other row and we can say that it is correct. But one thing to notice is that, for example, for this one, it is not going to just be the same number, because for these ones, the numbers that I have are pretty small and they don't have any carry. So here, for example, if I want to do that, it is going to be 10 to the power of 0 all the way to 10 to the power of 5. And if I compute that, actually see here I have 5 times 10 to the power of 4, but also here I have 10 to the power of 4. So what I will have is 161051. And if you check that, it is actually 11 to the power of 5. You can do the pattern. You will start from the rightmost one with multiplying that by 10 to the power of 0, going all the way to the left, and the first one is going to be 10 to the power of the number of row, and it is going to give you 11 to the power of number of that row. If I want to explain that, actually it is very similar to the formula that we used before by setting x equal to 10 and y equal to 1. Now you see that actually here it's like I'm multiplying all the n choose k by 10 to the power of n minus k, and for y I will have 1 to the power of k that I can just skip that. So it is going to give me 11 to the power of n, and you see that in this pattern as well. This is day 17 of my 30-day challenge in counting and combinatorics. Subscribe so you won't miss a challenge of day 18.